let's take a look at current and circuit diagrams. Basically what we want to do is we want to figure out how to build some circuits and then take some measurements of it. So we got to figure out what we're measuring. Last time we talked about voltage, which is the electric potential energy between 2 points. Now let's take a look at current. Current is the rate at which charge flows through a circuit. It's measured in coulombs per second, although we almost never say it that way. We usually say amps. So there's 3 different variables you guys are going to be measuring. There's voltage, which is potential energy per unit charge. Okay. There's amps, which is charge per second, and then there's resistance, which is measured in ohms. It has that funny upside down horseshoe symbol, and basically this thing limits current. Now I'll show you what I mean by that in a minute, but first let's get some circuit diagram stuff out of the way. Any circuit has a voltage source. Remember, we have to have something that's providing energy to make these electrons move. There's a couple different symbols for voltage sources. Usually a DC voltage source looks like this. You have 2 big lines, 2 little lines. The big line is positive, the little line is negative. So this is basically the symbol for a battery. Then you have resistors. Resistors don't have to be just a little ceramic thing, but a lot of times they are. The symbol for a resistor is squiggly, squiggly, squiggly line. Okay. Now, under resistors, we can put a whole bunch of other things. Anything that's an electrical load, that means it takes an electric energy source and converts it into some other energy, is technically a resistor. But a light bulb, it does resist current flow. A lot of times you'll see a light bulb written like this, a loop of wire through here and then a circle around it. Sometimes you'll actually see a picture of a light bulb. You might see something that looks like a switch. You might see something that looks like a LED. Okay, this is actually an LED, light emitting diode. That would be a form of resistor. It changes electrical energy into light energy. You might see switches in a diagram. Basically you have a point, a wire, and then another point. Okay, so this switch can open and close. Anytime you see wires that cross like this, that means this is a non-intersecting connection. So these 2 wires don't actually touch right there. They're just one overlying the other. If you see wires touch like this or with a dot, those wires do touch. And then, well, let's just take a look at a circuit diagram that we actually are going to measure. So one of the ones you guys had to measure was when you had a resistor hooked up to a battery. Now, basically what we do is we hook up the resistor and we have a path for current to flow. Anytime you're going to have a circuit, you have to have a complete path for current to flow. Then we want to measure 2 things. We want to measure voltage, which, remember, voltage arises because we have a positive over here and negative over here. We have a separation of charges. It's a potential difference between 2 points, a potential energy difference from one point to another. So when we measure voltage, we hook the voltage sensor up on this side and on this side because we want to measure a difference between those 2 points. So we would measure our voltage right here. Current, on the other hand, is actually the flow of charge through something. So if we want to measure the flow of charge, we need to hook the ammeter up into this circuit. So this wire actually goes into the ammeter and comes out of the ammeter. Okay, this will measure our current for us in amps. This will measure the potential difference or the energy difference on either side of that resistor for us in volts. And so you always put an ammeter as part of the circuit. You always put a voltmeter across whatever you're trying to measure the voltage of.